Jim, my name is Greg Cunningham. I've worked in the engineering and manufacturing sector for nearly 25 years, primarily with an emphasis on product design and managing product-related data. Been with Imagine for 5 years next month, and prior to that, I was with Autodesk. With that said, I would like to introduce my colleague, Dr. Scott Hoover.
Thanks, Greg. Good afternoon, everybody. As Greg said, my name is Scott Hoover. My role with Imagine is as a solution consultant for Fusion Lifecycle. By trade, I'm actually an industrial engineer and have been certified by Autodesk as a Fusion Lifecycle implementer. And I've been with Imagine for nearly 7 years now.
So today we want to talk from an agenda standpoint a little bit about Imagine and Autodesk, common business systems, or as I call them, 3-letter acronyms, discuss digital transformation, its impact on manufacturing, and then we will have Scott walk us through, the kind of the difference between a disconnected and connected collaborative product development process. Although we won't open up the mics until later, as mentioned, I do encourage you to put your questions in the chat window. Also, dogs barking, kids yelling, lawnmowers running in the background. This has all become the new norm. We embrace that here at Imagine It, so relax, don't worry about it, and enjoy the rest of the presentation. So, empowering innovation, Imagine Technology, pretty bold statement. With the staff of over 140 technical experts, instead of telling you why something can't be done, if you can imagine it, pun intended, we can help you do it. When you look at Autodesk, in 1982 they were founded, and with their flagship product, AutoCAD, it really forever changed how engineers, designers, architects created, almost single-handedly creating what has become known as computer-aided design, or CAD. As stated on this slide, Autodesk makes software for people who make things. So let's take a minute and take a look at some of those 3-letter acronyms I mentioned earlier. So PDM. PDM is a strategy for an engineering team to manage their product-related information and processes. PLM is a strategy for connecting the data, people, and processes across the product lifecycle throughout the entire organization. Then ERP is a strategy for managing business resources such as cash, raw materials, production capacity, orders, purchase orders, payroll, etc. Really the financial transactional side of the business. So you probably heard the term digital transformation tossed around quite a bit. You may have already written it off as just another buzzword. No matter how you feel about the term, the reality is that digital transformation is an imperative for manufacturers. So let's really take a look at what digital transformation means specifically in manufacturing. So digital transformation is the integration of digital technology into all areas of your business by connecting your data, the files and metadata that make up the source code or intellectual property for your product, the people, which is about the challenges your engineering and non-engineering staff have while developing the product, and the processes, which is about the challenges with maintaining standard procedures throughout the development. Shouldn't be surprising this kind of digitalization movement has reached manufacturing. Manufacturing generates more data than any other sector of the economy, which I was kind of surprised when I learned about that. Today, we can do things with this data that we're generating, we just simply couldn't do 5 years ago. And then technology advancements, robotics, artificial intelligence, like generative design, additive manufacturing, these technology advances, they really change how we create. As a result, product complexity has really increased. The business of developing, delivering new products has increased across multiple divisions. Customer needs, requirements, changing extremely rapid, at an extremely rapid rate. Increased contract manufacturing. Actually, 1/3 of companies surveyed said that they've seen a large increase in contract manufacturing. And then just more dynamic supply chains. So there's a lot of different challenges that are presented with, but what's really important to recognize, these are happening all at the same time. That cumulative increase in complexity is enormous. Design data management challenges, they cost businesses time, money. They also limit the amount of time that engineers and designers can really focus on innovation. For anyone who works with CAD files every day, it's probably no big surprise to see finding the right information at the top of that list. Going beyond just reusing the data, many engineers don't have a way to revisit past engineering decisions to get an understanding of the rationale behind those decisions made. For instance, why was a change to a certain design needed? And what approach did they take when they were implementing that change? This is all a lot of valuable information. So also, wasted engineering productivity is one of the most common reasons companies even begin considering PDM and PLM. In fact, of those surveyed, 20%, 20.3 as a matter of fact, said that they have challenges with technical resources, time being spent on non-value-added activities or tasks. That's really, it equates to 1 day a week for each technical resource. From a collaboration standpoint, collaborating with other departments, it's a top product development process challenge, but just as common are challenges working outside the company, such as with customers and suppliers. So PDM is really about managing your CAD files and helping people collaborate and work efficiently. The second phase to that, though, is PLM, which is about looking at the workflows and processes that are centered around the data, such as managing change, design reviews, project management, managing bill of materials, and so on. Review, sign-off, and release are strongly linked to compliance. And by compliance, what I'm really talking about are the specifications, policies, and standards, the internal regulations that dictate how you do business, how you handle projects, how you ensure customer satisfaction. All right.
Go ahead.
Okay, so if you're not sure why things are stalled, you find yourself buried in spreadsheets, emails, or just waste too much time on status reports and even potentially meetings, you've experienced the problem firsthand. Disconnection comes with a lot of risks that extend well beyond engineering. So what are some of the things that best-in-class manufacturers are doing about it? These are pretty significant results. So our recommendation is really start with an innovative approach to managing that product data. And with that, I'm going to ask Scott, introduce Scott, and let him walk through a little bit about what that can look like. So let me make Scott the presenter. And Scott, let me know once you have it.
All right, I believe I do. I should be sharing my screen. Can you see that, Greg?
Yep.
All right, wonderful. All right, so what I plan to do over the next few minutes is to first actually walk you through what we find to be as a typical disconnected workflow and what that really looks like and what different technologies and methods for transferring data are used. We're going to use an NPI process, new product innovation or new product introduction process as our example. Once we go through that, we're going to flip over and take a look at what a connected workflow looks like with the idea of doing the digital transformation and what technologies are used for that and how you can very greatly improve your overall processes by integrating and doing digital transformation of your data. All right, so we're going to start off with our disconnected workflow with a new requirement for a product. This could be a slight variation of an existing product, maybe a new model of an existing product, or this could be a completely new product line in your organization. Once that requirement has been identified, reviewed, and approved, any of the associated data is kind of thrown over the wall, so to speak, to the engineering group, typically through the use of either email or some PDF files, maybe a SharePoint or a share drive type of collaboration. Once engineering gets that data, they're going to start their process of designing out this new product. They're going to create a project folder, project structure within their PDM system, say Autodesk Vault, create their assemblies and component drawings using their design software. And typically as a end result of that, not only do you have your drawing files, but you also generate, the engineering team also generates a bill of materials. Once engineering has completed the initial design work of the new assembly or new product, they are going to throw that data over into the pre-production team. Again, they're going to provide this data through the use of an engineering change order, which in some organizations could be just done by email or by some type of tracking sheet, whether that be in Excel or a Word document. And even with some organizations, it's still a physical paper document and a physical folder of data that gets passed along to the appropriate people to continue the NPI process. But once this pre-production team gets a hold of this data, and more specifically the bill of material, they're going to go and add in any of the additional items that need to be part of the manufacturing bill of material, things like grease and oil, packaging materials, things that aren't a part of the actual engineering of the new product, but are still required for when we get into a production state with the product. And when the pre-production team completes their work, again, this data is going to get passed over to the production team. And somebody within that team is going to take this data, again, passed to them either via email, physical documents, Excel spreadsheets, and emails. And they are going to re-enter, more than likely, this data into their ERP system for the purposes of doing ERP tasks, such as purchasing of the raw materials or components, doing production planning, and so forth. But once all of that has been completed, entered into the ERP system, then we get to this point that we're actually in production. We have a product that is going out the door to our consumers and really completes the NPI process. Now, after a while, there may be an issue discovered with the product, or maybe the engineering team determines that there might be a need for a change to the existing product. Whoever determines that there is an issue, that data gets captured, typically in some type of email or maybe, again, a paper document, and gets passed to the engineering team through the creation of an engineering change request. And then really at this point, the engineering team takes that information, takes that data, and repeats the exact same process that we just walked through. And this becomes an iterative process as the life cycle of the product changes until the end of its life. Now, a couple things to point out here with this particular workflow is, first of all, you see a very heavy reliance on emails, Excel documents, PDFs, all of which may or may not be stored in a single location, like a share drive. Of course, if you've got emails, then each individual has their own emails with pertinent information within them and so forth. And if you have different versions of different documents spread out throughout the organization, it's just not a single location for that data. One of the other things you may have noticed is that there's the need to duplicate data entry. In particular, the example that I stepped through was the bill of material, and the idea that you get a bill of material from the engineering group, the pre-production team gets a hold of that bill of material, but may have to either recreate it or at least add on to it for the non-engineering items. But then when you get into putting that data into the ERP in a lot of disconnected systems, that is a manual entry of data, which of course can lead to mistakes caused by human error, simple miskeying of data. And then of course, with this disconnected workflow and the fact that you have data stored potentially in multiple places, there is no doubt that people are spending a tremendous amount of time looking for data or looking for the information that they need to be able to do their job. So I bring this slide back up, this slide Greg showed a little bit ago. I bring this slide back up for the purposes of, when we talk about digital transformation, these three key areas that we're talking about, data, people, process, I want to remind you of these three things as we get into what a connected workflow looks like using digital transformation. So we're going to step through the exact same workflow that we just went through a minute ago, but this is going to be vastly different than what you just saw because of the introduction of the digital transformation and the more collaborative workflow through the use of different systems. So one of the key things to start off with is that with this type of workflow, most of the data and the workflow processes that we're managing are all going to utilize the PLM system, in this case, in this example, Autodesk Fusion Lifecycle, and which is going to provide that single central source of truth for all of the data related to this new product that we're introducing into the organization. So like the previous workflow, we have a requirement that's defined. And once that requirement has been defined, validated, and approved, we have an integration. And I should say that this requirement, the process of validating, approving it, and reviewing and approving it is done in Fusion Lifecycle. And once it's approved, we have an integration that pushes that data into our PDM solution, Vault. And what the integration automatically does upon this transition is it automatically will create a new project folder and project structure within Vault, and then using Vault templates have the ability to have the drawing files automatically created, again, using those templates, so that the engineering team is ready to go with the new design of the product. Once engineering has completed the design work, they within Vault have the ability to promote the state of these drawings into a state that will push all of that data into Fusion Lifecycle. So you take all of the metadata associated to the assemblies, to the components and parts. You also take the drawings. But what you'll see in the workflow here is the integration will take the DWG or whatever type of drawing files you're working with and create PDF versions and attach those to the records that get created in Fusion Lifecycle for each of the assembly and components, thus securing your IP, the actual drawing files within the Vault, but then still allowing this data to be accessible to other individuals through the use of these PDFs. Again, all of that is done automatically with the integration upon the promotion of the state of the assembly and components within Vault. So now that we are into Fusion Lifecycle, the pre-production team is then, like our previous workflow, able to go in and add in the additional items to the bill of material that are going to be needed for manufacturing. Again, things like the grease, oil, packaging materials, whatever it might be. And then once the bill of materials has been updated, an engineering change order is created within the Fusion Lifecycle system. It is routed through its appropriate approval process. And then once approved in Fusion Lifecycle, that data, and specifically the bill of material data, is automatically pushed into the ERP system via the integration. This is done so that whoever is in charge of the ERP tasks, like your purchasing group, can go out and purchase the raw materials. Your production planners can go and start planning the production runs of the new product. But unlike the previous workflow that we reviewed, this is again done automatically. It does not require the need for that duplicate entering of data. And at this point, once we've got the data into the ERP system and we were able, we start producing, we again have completed that NPI process. But like our previous workflow, let's talk about the fact that we might have an issue or a need to change something within this product. So we identify that there's an issue. Within Fusion Lifecycle, we would create a record within the CAPA, or Corrective Action, Preventative Action workspace. We can collect the necessary data for this CAPA, and once that has been approved, we automatically generate an engineering change order to signify to the engineering team that there is a need for a change to a part or a component on our product. So we can identify on the ECO what component, what part that is. The engineering team is then able to go into Vault and then using the design software, make a revision to that component. And like a few minutes ago in our workflow, once they've completed the updates to the component, they are able to promote the state of that part to have the data be pushed into Fusion Lifecycle. The integration will then go and grab the specific component it is that we're dealing with and create a new record of that component with a new revision of it, or in preparation for there to be a new revision when the part has been approved through that ECO process. The integration also goes ahead and creates an updated PDF version of that drawing, and again attaches it to that new record within Fusion Lifecycle. All of this is linked together and provides traceability throughout the lifecycle of the component and or assembly. Once we have this updated data into Fusion Lifecycle, we can go through and complete and approve that ECO process. And then again, the integration is able to push that data into the ERP system to update it to determine, one, if there's any new purchasing that needs to take place, if there's any changes to the production planning that needs to take place, disposition activities, and so forth. And again, this then cycles on itself and throughout the whole life cycle of that product. So a little bit ago, we defined what that digital transformation is, the integration of digital technology into really all areas of your business. And we talked about how there are three areas that really impacts: the data, the people, the process. And I think as you saw through walking through this workflow, there's a lot of examples where we've touched those three areas. And to call out a couple, or one of each, with the data, we've created a repeatable process specifically around the idea of we've got drawing templates and a repeatable creation of those drawing templates so that the engineering team is ready to go with the appropriate drawing templates when they start designing. And very importantly, when we talked about things like the bill of material, we have eliminated the need to duplicate the data between systems, which can cause very significant errors if there's a miskeying of information. And when we talk about the people, by doing the digital transformation and integration of these digital technologies, we've introduced a system like Fusion Lifecycle, which really provides everybody within an organization that single source of truth for data pertaining to their products that they're producing. And it provides access to data that in a lot of cases, a lot of people would not have access to, talking about things like drawing files. Now, of course, we don't want to necessarily go and give everybody access to the DWGs or the actual design files, but with the creation of the PDF files and putting them into Fusion Lifecycle, you've now provided access to other individuals within the organization. You've provided that access to that data. And then finally, with process, in setting up a digital transformation and this integration of this digital technology, you've provided a very defined process that does not allow for deviations that you can typically see when you're using things such as emails and Excel documents and share drives and so forth. So I hope this painted a pretty clear picture for you of what digital transformation is and what the integration of digital technology can really do for you, within your own organization. So with that, I'm going to pass the baton back over to Greg, and he is going to review over a couple customer examples.
So thanks, Scott. One thing I'll comment, just from a simple analogy that I think of, when I think back to the days when I used to do a lot of solid modeling, and in some cases, in the early days of it, anybody can build, with minimal amount of training, anybody can build a solid model, 3D solid model. The real trick really became creating a model that behaved very well to change. That saved you a lot of time because it's inevitable that things change. You could definitely tell a model where someone had built it with, anticipating behavior, how it was going to behave when it changed. I don't see this being radically different from the standpoint of, as Scott walked through that connected workflow, fantastic from a development standpoint, no doubt about it. A great way to connect everyone in the organization to the product-related data as it moves through product development. And I've yet to meet or visit a company that didn't have a product or parts of a product change. In fact, it's a lot of what companies do in engineering is, the product's ever evolving. So I think it was pretty interesting when Scott got to the second part, where what happens when you have an issue. That disconnected workflow, that was a complicated process over and over again, each and every time that any kind of design change would occur. With what Scott presented, and there's many things you can do with it with connected business systems, but in this scenario, very, very suitable to rapidly making changes. And I talked earlier about all the different complications with product complexity and so on. I think there's a tremendous amount of value in being able to react to change very, very quickly. As evidence here, Husqvarna, Micron, one of their big things was their ability to improve documentation and revision control. Scott, if you could advance. York International, reusing design data more efficiently. And I think there's the part of that they're probably talking a little bit about a feature that many of you probably know, which is copy design, but also, how Autodesk is evolving and, adding more and more value to their tools. One of the new things that if you haven't seen or heard about it, that I think you will very quickly is, duplication. Have you ever wondered if you had a model sitting out, whether it's an assembly, whether it's a component, doesn't really matter, sitting out on your network drive, and there were multiple copies of that, maybe under different part numbers, different item numbers, things like that. A new technology that's available in fall 2021 is the ability to find and identify those types of duplicates to you. And to me, it does it on the geometry, which I find absolutely amazing. Scott, you go ahead. And then Aclara really leveraging Autodesk Fusion Lifecycle and Vault both to really streamline their MPI process. So we're going to we're going to open it up here in a second to questions. But when you think about a next step, generally we are not a boil the ocean strategy type of company. We do believe in helping you define the vision for your organization, but at the same time realize that there's going to be logical start points. You're not going to do everything necessarily that you intend to do day one. So what a very common first step for companies is whether you have Vault and whether you have Fusion Lifecycle PLM, whether you only have Vault, or even if you don't have either one of them, really this is probably on the front end a very, very good place to start is get your IP and all your processes integrated and working well together, and then as time moves on and at a pace convenient for you, then we look at potentially connecting up the back end. The real value, ultimate value of PLM is its ability to connect and integrate with all of your business systems. For today, we use Vault on the front end for the IP, and ERP on the back end for the transactional side of the business. So this can, for many of you, be a great starting point. With that said, I would just like to thank everyone for their time. And at this point, Laurie, if we could, if there are any questions out there, if we could just open it up for questions,